Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're back to working on the Tally-Ho Capstan project, and we're still working on this adapter flange. In the last episode, we made us a fixture to basically hold this part while we do some machining to it. It's one of the challenging things in doing machine shop work is sometimes you spend about as much time making a fixture to do work holding as you do actually doing the job, but it's just part of it. You have to be able to hold your work to be able to do it. And sometimes we have to make custom fixtures to do that. That's what we did. I did a previous video on how we did this. Basically, our adapter flange is just going to set up on this aluminum block. We're going to bolt it in place, and that will give us something that we can mill this thing on and hold it while we're doing that milling. We've got some pretty complex milling to do, some radius milling. We're going to be using the Kearney Trucker 2D rotary head milling machine. That's exactly what this machine was designed to do, was doing that rotary type work. This is all going to be done manual, no CNC, but we're going to be able to accomplish what most people would consider as a CNC job in today's world using an old school manual machine. Let me zoom in here, kind of show you what we got to do, and we'll get this thing bolted down and see if we can get started on it. So this adapter flange is going to bolt up to a pretty complex casting with a lot of different elevations in it. It's got radiuses in it and so forth. We need to be making good contact throughout that area. So again, we're going to be using the rotary head milling machine to do that. You can kind of see what we're starting with. It's just a circular block. And this isometric view kind of shows what we need to end up with. And I've got my coordinates and measurements and stuff to be able to mill these arcs out on here. And that's what we're going to be using this rotary head mill for, is to mill. We got to do three different things. First, we have to just cut a whole chunk out of the side. Then we have to step down and make a little bit wider radius. Then we also have to kind of mill out this front area down here. And then we'll have to go back and do some straight milling in the middle to open this pocket up to be able to get everything done that we need to do here. So again, this milling machine, this is exactly the kind of work it's designed to do. And got my fixture here. What we're going to do is, we got a pocket there for this little boss to fit down into that we milled on the machine. I drilled and tapped a couple of holes here. There's two holes that are not going to be basically milled away during this process, or maybe not milled away, but at least partially milled. So we're going to be bolting down on those two points right here. And that's what's going to hold our part in place while we do the rest of the milling. All the other holes are either this back one's going to, or front one, I guess. I'll have to figure out which one it is. I think it'll be the front one here will be totally going away. These will be milled down a step down, and these in the back will also have a step milled out of them. So let's get this tightened up. And I'm not too worried. It's got a little bit of play in there, but we will find the center of this part, and that will be our reference there. Once we get it bolted down, we should be in good shape for that. So, all right, I think we are ready to go. I'm going to put my touch probe back in here. I've showed how to do this before, but we can use that to find the center of this bored out area here. And then we'll go ahead and do our offsets and get ready to make our radius cuts. And I got my touch probe in. I'm going to lower it down here where we can go at. We are ready to find center with the digital readout. Basically, I'm going to touch in three places, two across one another, and then 90 degrees of that. So we'll go in here and do our running around. So first we're going to go left to right. We'll just go until I hear the beep, or whenever it touches off. It'll sense the very moment that it touches that part there, and it moves that probe just a little bit. Breaks an electronic circuit, and we'll hear a beep. Let's see. There we go. So now I'm going to go to point number 2, which is directly across from it. All right, and now I'm going to go somewhere about halfway in between. Doesn't have to be exact. And we'll touch off on the third point, and that'll give us I'll calculate the diameter of that hole, and then we can find the center of it using the digital readout. All right. But as you can see, the probe is in the center of where we want it to be. All right, let's figure out where we need to make the center of our radiuses that we're going to swing from. I'm going to take my touch probe out so we don't damage it, and we'll get set up to make our arcs. So just taking a look at our blueprint here, you can see this is where 0, 0 is right here in the center of the part. But where the center of our arcs that we're going to be swinging, it shows that we're up 4.301 inches, 4.301, I'm reading sideways, and it needs to come to me 0.117 inches. And that will identify the center of where we're going to be swinging our arcs from. And I've already dialed that into the digital readout. I'll show you that. And then we're going to basically re-zero. This will be the center of our milling. So I'm going to just go ahead and re-zero everything out right there. And we'll go ahead and get set up to start cutting some arcs. So again, looking at the digital readout, 4.301 and 0.117. So we've got that in there. And I'm just going to go ahead and we'll zero these out. And that will become our new center of our coordinates. I've got my table locked down right there, and we'll be using the rotary head now to actually mill those radiuses. So as I showed kind of in the last video that we used this milling machine, it has the unique ability that you can actually offset the spindle and rotate the head around. I got it set on 0 degrees right now. Let's see here, get it going, there we go. But as you can see, the whole head up here rotates around. Let me get back over here to 0 degrees. And I can also move this head in and out to a specified diameter, or a radius rather, and swing an arc and actually cut a circle. So according to my plans, I need to cut out a circle up here that is 2.598 inches as a radius. So the diameter will be twice as that, but 2.598. Now I've got a 1/2 inch end mill in here. So basically I need to subtract 1/4 of an inch or half of my 1/2 inch radius, 0.250, from that, because we're going to be cutting on the outside of this circle. So we kind of have to add that to this. So I need to move my head or move the spindle in 2.348 inches. So there's a scale over here on the side, and there's a micrometer reading here in the front. So basically every time I turn this spindle 1 revolution, it's 100 thousandths. And over here on the side on my scale, I can just read off of that, and that's going to be in tenths of an inch. So there's 10 divisions in there. I need to go to 2.348. So let me dial that in. I'm just going to go to 2.3 on my radius up here. So we're just going to dial that in. That's 1 inch. That's 2 inch. 100 thousandths, 200 thousandths, 300 thousandths. Now I can work off my dial. It's actually 300 right there. Just confirm. Yep. So we're at 2.3, and I need to go to 48. So I'm just going to read that on my dial here. That's 10, 20, 30, 48 right there. I'm going to tighten up these. That'll tighten up the gibs on this so that it won't move in and out any farther. We'll lock it in place. Finger tight that one. And now I can crank my handle around, and that's going to swing an arc and cut the radius that we need. So, and I did, just to kind of confirm things, this is a rough template. I just used a compass and set it and put an arc on there, and I cut it out with a piece of scissors on some paperboard. But this will kind of just give me a visual to see how close I am. I will tell you guys that these radiuses that I'm cutting, they're not super critical. They're just for clearance. So I haven't got to hit it dead nuts on. We're going to go with the numbers that's on here, but it should get us dead nuts on, but we've got plenty of wiggle room. So I can kind of verify where I'm at using that. So let me, I'm gonna raise the head table up, I think. All right, so I should be able to turn on my head here. This does have a mechanical, so I can let the machine swing it around for me. I don't have to crank it by hand. For that radius that we're cutting though, I think that's a little bit on the fast side, so I'm gonna change. Right now we're set on making 1 revolution per minute. I'm gonna take it down to half a revolution per minute. I need to change my gear saver here to be on BF. So, a little bit slower swing on that radius. Alright, we will kind of move out to the edge there. Zoom in here, you can see what's going on better. I'll feed down just a little bit. I just want to make a very light pass, this first pass across. Just enough to kind of see where we're at. Just going to feed down a few more thousandths. Alright, we're going to let that swing across. Alright, we're going to let that swing across. That looks good. According to the drawing, the radius here is supposed to be just shy of this radius of this inner circle, and we are right there at that intersection point. So I think we're about where we need to be on our radius. I'm going to let that come on out. I'm using my little template gauge here. I'm just going to come in here and, you know, that is matching very nicely. That's going to be perfectly fine. So what I think I'm going to do is I'm going to see if I can do 100 thousandths per pass, and we're just going to basically swing that arc, and I'm going to just cut this whole piece out. This whole piece has got to be out of the way, so we're just going to go ahead and just go all the way down until it disappears. So we'll just zero out our Z-axis over here. I can keep track of my heights. We'll raise up 100 thousandths. Should be right there. And take her for another ride. Let's see how this cuts. About 100 thousandths step to cut. Got a 4-flute carbide end mill in there. It appears to be cutting just fine. Going to let it go back. This is the shorter way to get to the back to the starting point. So we'll just do that, and then we'll raise up another 100 thousandths and slowly equal the way. All right, add another 100. Take her for a ride again. put in another 100 thousandths on our depth. And away we go again. And this is so cool. This is really the first, I guess, true job I've done on this rotary head milling machine, using this rotary head function like this. And one of these things you don't have a lot of use for, but when you need to do something like this, this is a really handy feature to have. And that was just cool. I'm really happy to have the functionality of having this machine in my shop and being able to do this kind of work, because it comes up from time to time. Alright guys, we're going to just continue on down until we kind of get this eaten away. I'll bring you back when we get kind of down toward the bottom. We're getting down the last couple of passes here, so I'll bring you guys back. So far so good. Seems to be cutting very nicely. Nibbling away. Looks like we're going to be just shy of going all the way. We'll have to make another pass. No problem. Back around, and this should be the last pass. Not sure if I've gotten any aluminum yet or not. There we go. We're actually taking about 120 on this pass, but I'm going to go ahead and do it all in one pass. Here we come around, and I'm going to kind of come in here and hold this slug. Just try to make sure it doesn't try to cut back on itself when we come out the end down here. There we go. All right. That worked very nice. Well, guys, I think we're at a good stopping point for this video. We got this piece cut out. We've kind of got the machine set up to start cutting these radiuses. I've still got a couple of more radiuses to cut, as well as some other milling on this part to get it finished up. And it's going to be more than we can put in one video. So we're just going to go ahead and call this one here. And we'll come back real soon and finish this piece up and move on to the next part on this Capstan project. It's been a fun project so far. Guys, with that, it's going to be a wrap. As always, thanks for watching. Please do subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Hit that bell icon up there to get notification when new videos are posted. And as always, thank you for those who subscribe to the channel, as well as those who support the channel financially through Patreon and PayPal, which really helps me be able to take the time to shoot these videos, edit the videos, bring them to you. On top of everything else we try to get done around here. With that, guys, we will sign off. We will catch you on the next video. Again, thanks for watching.